you to the GTRI Virtual Bootcamp for Operational Efficiency, or basically the bootcamp to introduce you to Splunk. So our presenter today is Micah Montgomery. He's a Splunk architect with a lot of experience. He'll be presenting the material today. And just brief introduction to GTRI. GTRI is a solutions provider out of Denver, Colorado. We have a lot of experience with Splunk. We were the first Splunk premier partner. Why would we do this? And especially, why would we do this for free? The reason is because we believe Splunk is so useful and so unique and so powerful that once you are introduced to it, you will see the value to your organization. Now, of course, we provide Splunk professional services, Splunk licensing, Splunk training. So we hope that you would consider using us for your Splunk services if you decide to install it and you find a need for these services. So that's the reason behind this, but we're going to give you a lot of high quality material here, and you will be able to see from the material we provide how to use Splunk. Now the fact is, you can download Splunk for free, and you can use it for free as long as you index less than 500 megabytes per day of incoming logging messages. And you can use it for free forever, as long as your incoming amount of data is less than 500 megabytes per day. So Splunk makes it easy for you to start with it, to use it, and the trial version that you get, the copy that you download, is full featured and has all the capabilities. So with that, I am going to turn this over to Micah and let him start presenting you the material.
Welcome, everybody. Like Avi said, thank you, Avi. My name is Mike Montgomery. I'm a Splunk architect. I've been doing this I don't know, not full time, but for a couple of years now. First ran into it about 5 years ago for some of the same things we're going to talk about today. So hopefully you guys have at least heard about Splunk. We're assuming a little bit of knowledge, but not really. We're going to go over some of the basics, and we'll get into some of the little bit of depth here and there. But really, our purpose and the purpose of these boot camps is to get you guys hands-on with the product. We find that as cool as our data is and as cool as we think it is, it's not nearly as much fun for you guys until you can get in and start looking at it and start thinking about how it can help you in your environment. It's really, we've seen some incredible reductions in mean time to repair, things like that, using Splunk to troubleshoot. And that's really what the purpose of this particular boot camp is. And I don't know if you guys knew it or not, but you guys are our guinea pigs. You're our first live class with this material. So we think it should go pretty quick, but some of the timing may be a little weird. And, you know, if we're a little rough with some of the transitions, please bear with us. The information is good. I think that, in fact, this is my favorite one we've done so far. And I'm really excited about it. I think you guys can get some good stuff out of it. So we'll go ahead and roll through it. Just a little bit of housekeeping. So there are some files in the download window. There should be 3 of them. There is the Prezzo that we're going to go through today. There is the exercises or the lab document we're going to go through. And then there is a list of logs. Also, I would go ahead and take a moment and download all 3 of them. So I will show them to you here in just a minute, and I will show them to you throughout. But it's going to be better for you guys to have a copy of it as well. There are some notes in some of the slides that may be helpful in the future, and I'll be using them to do some of the demos and in the future. If you want to refer back to them, that's why we provide it. So there are a couple of scripts that we use that will enable and disable certain events so that we can show you guys what it looks like. So if you guys are overachievers or impatient and you're jumping ahead, it may not look like it says in the documentation, or might not look like the pictures. So this is live data. It is scripted live data, but it is live, and what you're going to be looking at is coming in as we're looking at it. So again, if you're jumping ahead, that's great. Feel free, but it may not always look like you think it should, or like the lab doc says. A little bit of other housekeeping. If you have questions, love questions, especially with this material since it's brand new, you can shoot them into the QA window. or you can put them into the, where did my QA window go? Or the chat window. So the chat or QA, Avi's here to help us with that, so he will probably be responding to most of the questions. If there is something that you would like to ask, let me know, and I can unmute your mic, and you can just go ahead and shout it out, and we can talk about it that way. So I'm pretty laid back when we do these things. I think questions are very. Let's see. Sorry, I got a question there. If you can't see the file menu up at the top, when you go up to the top, it'll pop down the menu. If you click on the little wedge, you should be able to find it there. Let's see. Oh, where is that? I don't know. I'm going to actually turn this one over to Avi so he can get to the transfer. This looks like there's a question there. If you want to throw it into the QA window, everyone can see it, and it's easier for us to respond to it. If you have a more private question, then throw it into the chat. QA window, go. There we go. Perfect. All right. So once the files are downloaded, should be good to go that way. A little bit more detail about some of the things Avi talked about. You know, we do this to for the Splunk community to raise awareness and kind of give people hands-on look at some of these tools. But we are also a solutions integrator. We've been around for 14 plus years now. We do a lot in the Fed and commercial space. We're about 60-40 split. We've got a lot of people on the Fed side. We've got a lot of people on the commercial side. ISO, pretty cool stuff. These are first couple of slides here. Bear with me. There's the marketing slide. The marketing guys make me do this, or I can't, you know, do the whole bootcamp thing. So let's see here. There we go. Practice overview. You're the first elite partner, one of only 2 certified training centers in the U.S. We are one of the very few integrators out there that can do the whole shebang from beginning to end. And we can take you from intro to Splunk all the way into preparing you for the architect exam. So on the training side, we have most of our architects that we use. There's 5 of us. Most of us have 10 plus years of experience with IT. Well, all of us have 10 plus years of experience on IT. Most of us 3 to 5 years of Splunk and in large environments. A couple of the guys come out of environments where they were managing 10, 13 terabyte installs of this stuff. So it's not just book learning. We don't just go to a training and say, hey, we're experts. We do this thing kind of stuff all the time, day in and day out. So we have 6 core functionality. These are 6 core partners. This is our focus. So we do a lot of stuff outside of this, but this is our wheelhouse. So promise we're almost done with this, and we can move on and get into the good stuff. So everything from Cisco Master Security, Cloud Builder, you name it, with Cisco, very deep there. Citrix partner, highest level Citrix NetApp, and Splunk. Okay, enough of the marketing stuff. Hopefully it wasn't too painful. And if you do have more questions, feel free to hit up. So our agenda for today, what we're going to do, this is our goals. We want to provide a fundamental understanding of the components of Splunk, give you a little bit of hands-on, and send you through some labs. Now these labs will cover material that I'm not going to talk about necessarily. And some of the stuff that I talk about won't necessarily be in the lab. So there's some overlap, but a lot of it is meant to complement, not necessarily duplicate. So if you do run into any questions during the lab, please let us know. Again, this is our first run through with this, so if there's something that we missed or it's not very clear, let us know, and so we can adjust it going forward. So, okay, topics. We're going to do a Splunk overview, a Splunk architecture overview. We're going to go over data collection, Splunk for discovery, some automation, and then a little bit about Splunk apps. So, what is Splunk? Well, Splunk is the engine or platform for machine data. It's kind of evolved out of a program. It used originally the tagline was Google for the data set, and I'll show you why here in just a second. And it really did start out as simple as that. Let's try and make this machine data available and useful to everyone. Because machine data has always been useful to certain segments, right? Your admins, your people who are responsible for making the systems run typically can get into a log file, look it up, and actually solve their problems, right? But if you haven't seen them before, they're not the prettiest and or easiest thing to look through. So let me just jump over, and I'm going to show you. And this is the pretty view, and that's not where things start. So let's talk about what a live data flow looks like. So I'm just kind of walk you through data from the ground up and kind of real quick what some of the things that Splunk can do for you. So this is a fairly typical log file. Looks like these are, they're web server logs, probably. Yeah. So this is very standard. A lot of really good information, a lot of information that business folks can use to make better business decisions. But the problem is sorting through it and aggregating it, very, very difficult. So you can do it, and people have been doing it for a long time. It just is very manual, very intensive. And each one of these files typically comes off the server. And in today's environments, the last production environment that I was responsible for, we had 120 servers. So if we had a problem, we had 120 different servers we could have had that problem with. And to dig back through those log files was non-trivial. We had to go to each one, or eventually we had a log aggregator, and then we went to Splunk, and it was much, much easier. But it really can be very difficult to aggregate this kind of data. So we've kind of taken it from here, and the first thing we do is we just make it searchable. Back to that Google for the data center, right? So if you're looking at Google, you just kind of start typing, right? I don't know what I'm looking for necessarily, but I know we had an error. So whatever I put in here, it's just going to do a search for it. It's going to search through every event, every bit of data over the time period that I specify. And in this case, I'm looking at all time, and look for the text string error. Okay, so very, very basic. Anytime you see error. So in here, you'll see an error as part of a file name. You see error as part of a result code. You'll see error all over the place. But anytime you see that particular text string, that's what you're going to get. So maybe I'm looking for failures. So you can include things like the asterisk to make it more generic, to give you a more generic view of what you're looking for. Now, one of the things Splunk does, you'll see, and we'll talk a little bit more about this as we go along, this field extraction here along the left. Along this side, you see that this data will change as the search changes, because it builds this based on the data in the search. So if I look at error, or errors, or any variation of it, notice that I have 75 more fields, but my fields have changed based on the type of data. And I can start analyzing, what am I seeing errors? Well, these are the different source types. So it looks like I've got my some squid logs, some Linux logs, some WebSphere, different source types. These are the hosts that they're coming from, the actual devices that are generating the event that contains the text string error. So real easy to start digging in. And in fact, we'll get into this a little bit more. Right now, I just want to give you the 50,000-foot, 90-mile-an-hour view. So from there, we can actually take this and build some really interesting dashboards. Now, keep in mind that these dashboards are going to update as we're looking at it, because it's using that real live data to generate this information. So it's not a week old or a month old or anything like that. This is actually what's happening on the system at this moment. And this particular view is for CEO. It's meant to be a high-level executive overview of what the metrics are that are of value to that particular executive. So we've got some promotions over here, so we know what promotions are important or what are working. We've got coupon usage. We've got abandoned baskets. So this right here, and it's a demo. We built some problems into it. You notice that there's a lot of abandoned baskets, and there's some specific reasons, and we can dig into those. And if we have time, I'll kind of walk you through that, depending on which direction we end up going. But just some very good information, and all of this is buried back here in this live data flow. But digging that information out in a manual fashion, very, very difficult and time-consuming, and pretty much guaranteed to put most people in a rubber room at some point. Very, very tedious. So what we've got is Splunk to help us visualize that stuff, to take this type of data, this text data that contains what we're looking for, and turn it into things that maybe your admins can look at. So let's get a quick top-down view, real-time look at what's going on in our environment. And let's look at our 7-day average and the transactions for today and kind of look and see how are we doing. Okay, we can use some of these like dials and speedometers and really get a view at a glance of what state our system is in. We can tell right now that we're in our SLA infractions. You know, right now we can tell we're in the red. We've got a problem. We've got something we need to check into. And again, this is a demo. We built this stuff in, but this is very much real life scenarios. So anyway, that's just the real quick overview. I'm going to flip back over to our, let's see here, back over to our slides, and we'll keep moving. But that's really, we're going to spend more time on the interface. The whole point of this is not for you guys to listen to me flip through a slideshow. And you know, as cool as slides are, and as great as they are in their information, they're not very exciting, and the attention isn't good, I find, as if you're in there doing it yourself. So our whole point is let's get you to doing it yourself as quick as you can. So there's our overview of Splunk. It's an engine for machine data. It can ingest any type of human-readable log data. And we'll talk a little bit more about data sources here in a minute. But when I say any, I really mean any. If a human can read it, Splunk can index it, make it searchable, make it dashboard, and visualize it for you. So how is Splunk used? These are some of the traditional use cases: application, security, SOC, NOC. We're going to talk a lot about NOC today because it's kind of the day in the life of the NOC, and we're kind of taking this particular view from that. So we're going to talk about troubleshooting and how to short circuit some of that time to resolution and really make life a little bit easier on the people who are responsible for keeping things up and running. That's really the point today. Now, there are a lot of other custom use cases, SCADA data for the energy folks. I know a guy who, one of the Splunk guys, was a little, I don't know, a little overly zealous, and he actually put intelligent electrical appliances, or not appliances, but electrical power grid into his house so that he can actually Splunk his house. And he can tell you what room is consuming the most amount of energy, whether it's somebody left a curling iron on, and all of that. Very, very interesting data source and what he can find from that. Another one that I like is kind of an interesting illustration of machine data and some of the non-traditional uses. Is there's a company actually out of Hong Kong that are actually Splunking their elevator data. They are watching the elevators. They're seeing how many times they stop on a given floor, how often the doors open, how long they stay open. And from that data, they can determine with a 75% accuracy whether or not someone is going to renew their lease. So they can actually get a jump on the fact of renewing the lease or finding a new tenant for that floor or that suite based on their elevator data using Splunk. Not something I would have thought of, but it's really a cool use case. And it really does just go to kind of illustrate some of the cool things you can do with non-traditional machine type data. I don't know about you guys, but I hear a lot about big data. And big data to me is the next cloud, right? Cloud being, it's really cool, it's really exciting, and everybody knows and wants a cloud, but nobody really knows what the heck cloud is. Today, it is really, you know, a couple of years later down the road, cloud is becoming more clear. It's more defined. We've got software as a service, infrastructure as a service, you know, these different cloud offerings that have developed to really fill that space over time. And I think if you look, big data is kind of in the same situation. There's a lot of buzz. There's a lot of possibilities. A lot of people are excited about big data. Big data, woo! I use big data. But nobody really has a good handle on what is big data. And really, big data is a very personal subject. The best definition I've heard for big data is the amount of volume, variability, or velocity of data at which existing tools start to break down because of one of those factors. So, big data, it will become clearer over time, and it will clarify, it will solidify, and it will be more of an industry-accepted term, and people will know what you mean. But for today, big data is really this amorphous mass of cloud of yesterday, right? So what is big data? So all of these use cases I talked about are just simply to illustrate some of the uses that people have found for this data. There is a lot of really good information in our log files. These machines generating this data, I mean, terabytes, petabytes more of data that we're just not getting any value from other than maybe marking a compliance checkbox that says we have to maintain these logs for X number of days. So if we've got to do it, we might as well see what value we get out of it. And as IT folks, if we can start showing value to business, like that CEO dashboard I showed you real quick, if we can give business people data to work on in real time, how valuable is that to the business? How valuable does that make IT to the business? And really, that is where IT has to evolve in order to stay relevant, right? We need to be able, as IT folks, to enable business folks and companies to be more efficient and effective at what they do. And that's really kind of the highest level of IT functionality. So anyway, that's a little bit of my soapbox. Anyway, use cases really is as varied as the people who use. Yeah, I know a guy who Splunks his fish tank. He monitors his, he's got an intelligent meter and salinity, all that, and he Splunks overtime. So, interesting use cases. Well, if we have time, I'll talk about South by Southwest if you guys have heard about that. And another way, guys are guys, and they found a way to use Splunk to actually meet girls. So, if you're interested in that, hit me up later, and I'll send you the link. You can look at South by Southwest. Very interesting stuff. All right, so let's talk about Splunk. This is kind of the architecture that makes it all go. So it's divided up into four different functionalities. Fourth would be the deployment server. We don't show it on here. It really just manages the deployment. It doesn't really do searching and interaction like that. So, searching and reporting is done by the search head as the user that's what you interact with. So when you log in and when you log into our system, you're going to be logging into the search head. And when you launch a search, you talk to the search head. The search head will then submit the searches to the indexer. The indexer is the heavy lifter. It's the workhorse. It does most of the data, most of the heavy work, right? It indexes the data. It does the searches and returns the results to the search head. Forwarder is a universal forwarder. We call it a collector, right? I've heard a bunch of different words for it. But basically, it's a way to get the data from wherever it is into the indexer. They're typically very lightweight. The only exception to that is if you need a heavy forwarder, there's, it's very flexible in the implementation. But the forwarder just gets the data from wherever it is into an indexer, and indexer indexes the data, makes it searchable. The search head is what you interact with and actually use to start leveraging that data. So these can be a Splunk install, can be any or all of these roles. With Splunk, you actually have two installs. I mean, for different platforms, but they're basically two installs. You have the forwarder install, and you have the main enterprise indexer, or the main Splunk enterprise install. Everything else is done by configuration files. So what you'll be interacting with today is one of these. All of these roles will be condensed onto a single server. And that's typically where people start. Let's talk a little bit about a multi-tiered environment. So if it's all collapsed onto a single environment, I very commonly run these on my laptop when I'm doing demos for people. I have a Meraki set up in my house, and I actually use Splunk to monitor that. And that's all on a single server. So a single server will handle, depending on your environment, the size of it, whether it's virtualized or not, can handle anywhere from up to about 10 to 100 gigabytes a day. So that's kind of where you start needing to break things out. There are other factors. One thing you'll find as you kind of work your way down this Splunk journey is that it is a lot of art to the science of Splunk. So there are maybe 10 ways to do it. 9 of them are the right way, and you just get to pick the one that makes the most sense to you. So there's a lot of right ways in Splunk on how to do things. And that's one of the things that we as GTRI can help you with that. We've done a lot of these. We know kind of some of the pitfalls to avoid, and some of the we can kind of accelerate the pace here. Nothing. We don't know any magic. If we did, I don't know that I'd be working here. I'd be having a lot more fun in Vegas or something. But we can actually short circuit a lot of that work. Not that you guys can't figure it out on your own. Enterprise scale, the way this scales is very linear, and it scales at every tier. So if you need to get more data in, you can add more forwarders. If you need to index more data, you can add more indexes. If you've got a bunch of people searching on it and running some complicated correlation searches, you can add another search head. And you can have any combination of those running under a Splunk system. So you can have 10 search heads and an indexer if that fits your environment. You can have 10 indexers and a search head. You can have 10 indexers and no dedicated search head. It really just depends on how you're using it and what kind of performance you need. The good thing with Splunk is it is software, and sometimes that can be a little bit challenging as well. Splunk is not an appliance. It's not hardware. It is simply software. It is designed to run on white box hardware or on your VMs. There are some issues with VMs, mostly around disk I/O, to be aware of. That's really the only concern there. And that really is most platforms that runs on very, very ubiquitous almost. I haven't found anything lately that won't run on. Okay. Our operating system, 32 or 64-bit. Highly recommend 64-bit on the server. Let's see. Looks like I got lost an audio note in here. Can you guys hear me okay? Okay, looks like, all right, sorry, I don't know what's going on with the audio, but if it goes in and out, if you open up the participant window, you can actually throw some feedback my way. There's a little check mark that looks like in a bubble, and if you need to open up the participant window, you can go up to the top, and there should be a button there with a couple little people on there that'll pop up the participant window. And you can put in yes or no, a check mark, or too fast, too slow. If I see any red checks, I'm kind of keeping half an eye on that. So if I see that, that would be, just let me know that there's a problem. Otherwise, I will be talking to myself, and I don't need that. My wife will give me a hard time enough as it is. So anyway. All right. Very good. So I'm going to clear the feedback for now. So if you have anything come up, shoot it into my feedback window or into the chat window, and I'll keep an eye on it there. All right, moving on. We're almost to getting you on the system, I promise. So that's a little bit about operating systems, and now let's talk about lab access. So there is a file in that download window if you can get access to it. If not, let me throw it up here real quick. Other windows, so you guys can see it, not this one. So here are the logins. The link is on the slide. It's basically bootcamp.gtri-training.com. It's on standard port 80. It is not encrypted for this particular one. The only one we encrypt is the security bootcamp when we run that one. So what you're going to want to do is go through exercise 1 or lab 1. Where did my lab 1 go? I know I have it. There we go. Okay. So here's lab 1. It's basically just what we're going to go through is just getting connected. So I want to make sure you guys all have the basic lab access. I want you to log in. I want you to edit your account, change your password, and time zone. The reason we give separate accounts is we're going to be creating some knowledge objects, and it's not going to kill anything if you guys are using the same account. It just will look a little odd. So go ahead and get logged in. Find your name on the list. Find your student login. Go ahead and log in. And I'm going to give you 5 minutes to get all this handled. Make sure you get everybody in and logged in. So let's see, 40 after the hour is pretty close to that. So once you guys have gotten logged in, I want you to go ahead and throw me a green check mark using that feedback I talked about. And if I see everybody's done prior to the 5 minutes, then we'll go ahead and get started a little sooner. Otherwise, we'll go ahead and get rolling again in about 5 minutes. Excellent. For you guys that are already logged in, I'm actually showing some stuff here on my screen. And this is the new pivot. We'll maybe spend a little time in this or not, depending on how much time we have. But this is just one way to manipulate data. If you work with pivot tables in Excel, it's very similar. We can define a data model, and then end users can use that data model to really slice and dice the data however they like. So I'm just poking around here. I'm kind of keeping an eye on you guys to see who's logging in and who's not. So, and also who's running circuits. So just kind of ignore me, get your, or if you're already logged in and ready to move on, you can kind of keep an eye on what I'm doing as well. So it's just up to you guys. not really fair to compare the admin to you guys. Looks like somebody's been poking around. Go on. All right, looks like we're about coming up on 40 after the hour, and let's see how you guys are doing. Looks like we got a few check marks. So this is pretty important. We want to make sure you're able to get on and use the system. So if there is anybody that is not able to, let me know. If you're wondering what to do once you've logged in, you can look at the exercise files. What are they called here? What's this file here? What is it called? Lab document. So the GTRI Operational Efficiency Lab document will tell you exactly what it is we're supposed to be doing. So for this exercise, all we're doing is we're logging in, we're changing our password and the time zone. I mean, you can leave the time zone alone if you want. It's not a requirement. It just means you're going to be doing some time zone translation in your head, and that always gets me into trouble. So I usually like to set the time zone just to make it a little easier on myself. So it just changes your view of it. It doesn't change any of the underlying data at all. So, all right. Looks like most of you guys are through that part of things at least. So I'm going to go ahead and clear them for now. If you have any trouble, again, throw up a red check mark, and we can fix it from there. All righty. So moving on. All right. Data collection. Know your data. Somebody's got to know your data. Usually, there's at least one person within a company or an organization that is very good at their data. Somebody knows it. Somebody has had to learn it over years, and they've got some scars to prove it usually. But somebody has to know your data. So you need to know what it is you're trying to solve, what questions you're trying to ask. The way Splunk is licensed, it's very simple, and it's strictly based on the amount of data indexed per day before it's compressed. So that's the only thing that Splunk cares about. You can run 50 indexers to do it. You can run one indexer to do it. You can have 50 search heads, 50 forwarders, all that other stuff doesn't matter. The only thing that matters is how much is being written to that index per day. And that's what their license based off of. So really it comes down to what questions you're trying to solve. Because Splunk's answer is to index everything. You never know what you're going to do. And to some extent that's correct. Especially in security use cases with the APT kind of threats, you don't know what you need to know until after you need to know it. And so collecting as much as you can is a good idea, but it's also a little bit self-serving in the fact that that's how Splunk makes their money. The more you index, the more they charge you, and that makes the Splunk world go round. So that's fine. Again, there's value in that data, but really it comes down to what it is you're trying to solve. If you're trying to look at log usage or internet usage data for your website, well, you're going to need to be Splunking your website logs. If you want to do some correlations between logins and firewall rules or changes or VPN, you need to be indexing the logs that contain the data that you're interested in. Splunk's not magic. It won't go out and grab the data or invent the data just because you're interested in it. You have to be able to know what it is you're looking for and get it in there. Now, do you have to understand your data before you start indexing? No. That is one of the strengths of Splunk, and it's one of the big B's, right? Variability. Traditional data was very structured, and it fit very well into rows and tables. And once it was in there, and once you had that structure applied, it never changed, and it never changes, and so life is good. And only in La La Land. I've never seen that happen. Every time people go in and start upgrading things or even patching things, sometimes the log format changes. And suddenly, your nice, pretty data is all over the place. So with the way Splunk is designed is to handle that and to do it on the fly. So you don't necessarily have to understand your data prior. You just really need to know what questions you're asking. How long do you need to keep your data? How long do you need it searchable? Is there access control you need on your data? Is there some data that some people need to see, but not everyone? Typically, security data falls into that category. So the better you know your data ahead of time, the easier it is going to be to apply the structure to it. All right, where is your data? Always important. Splunk can digest it all, pretty much. We just need to find a way to get it into Splunk. Syslog's a common way. If it exists on a disk somewhere, we can either use a universal forwarder, or we can copy those files. We can grab it, we can pull it, we can push it. There's a lot of different ways to get data into Splunk, and a lot of different types of data that we can manage. So it really, again, comes back to the use case. The longer I've been in IT and the more I do what I'm doing now, the more that use cases change. Use case really drives everything else that we do. So we need to know what the use case is and what it is you're looking for in order to know what log files to look at, know how long you need to keep it. So really, it just comes down to what is it you're looking for. Now, if you don't know what you're looking for and you just want to kind of know what's in there, there are some things we can do to help with that. We can kind of, if you're looking for operational data out of your web log, I'll show you some stuff out of that today, some of the things that other people have done. And we'll talk a little bit about apps kind of towards the end, and that will address some of that as well. But really, the clearer you are on what it is you need to solve, the easier it's going to be to solve. Inputs. Okay, these are the different types of inputs, files and directories, inputs, scripted. They all have their place and function, and it really just depends on what it is you're trying to grab. So again, this is something we as CTRI can help you with. There's a lot of good documentation out there. A lot of times it just starts with a file. You have a log file that you're interested in. You can read that into Splunk very easily and start working on it and looking at it. Or maybe you have a stack of log files from a bunch of different servers that you want to be able to search all at the same time. So you can start very simply, and it can get very complex depending on the needs of whatever it is you need to do. All right, lab number 2, exploring the Splunk interface. So this is kind of a step-by-step discovery for different files, sources, and source types. So this is kind of a little bit of a challenge exercise. You should be able to go through and using the lab document, you should be able to do some exploration and kind of find your way down through it. So, all right. Let's see here. I'll bring up lab 2. Just 10 minutes for exploring the data. So I'm going to give you a few minutes to go ahead and run through this. And I probably will run through it too, just to make sure and go through it. So if you want to watch me, I'll be doing it on my screen. But my challenge is to do it on your screen. And there is also a challenge question. The last task in all of these labs is going to be a challenge lab that you can do if you want a little bit more depth, or if you want to take it on. So none of them are that difficult, and in fact, if they're too easy, let us know, and we'll come up with some harder ones for you. So it is 47 after the hour. Let's go ahead and go till, I'll check back in at about 5 till, and we'll see where everybody's at. If we're good, we'll probably just go ahead and roll on. If not, I'll give you till top of the hour to go ahead and finish it. just clarification on the particular slide you're looking at right here. Lab review, going to talk a little bit about the lab, make sure everybody was able to get through it without any problems, and hopefully get some good information out of it. The keyword searches themselves are not case sensitive, but the Boolean operators are case sensitive. So if you just put lowercase or in there for or, it will look for or in the text. It will not consider it an operator. So be aware of that. Now, there are some things, some parts of the circuit that are case sensitive. When we start getting into field names are case sensitive. So sometimes you will see fields with different case listed separately in the field selector on the left-hand side. And if I notice that, I'll show it to you. But field names are case sensitive. Text is not. You can make it case sensitive. There's a command for that, but I don't remember it off the top of my head. So just a quick note on that. It's about, we're a little, let's see, about 3 till. So let me check and see how you guys are doing. Looks like we've got a few check marks. Let's see, I'm going to clear those. Too fast, too slow. You guys want me to talk while you guys are working? We do have quite a bit of ground still to cover, and I usually like to give you a little bit of time at the end to finish the last one. So again, this is the first time we've run through this. Too slow. All right, we'll get moving. I usually like to give you a little bit of time going to go through things at the end. So we'll usually end up a couple of minutes early, and you can stick around and finish it up right then, or you can jump off and move on to the rest of the day, depending on what your schedule allows. We will leave the server up until about 10 o'clock Mountain Time, which is where I'm at, and then we will bring it down. So if you want to get back on later and poke around and log back in, those logins will be active all the way up until about 10 o'clock tonight, depending on when we jump on and close that server. All right, so let's move on. If you guys are still working on it, feel free to keep working on it while I'm yapping in the background. I'm going to talk a little bit more, and then we are going to get into another lab fairly quickly. Again, as cool as my voice is, I'd much rather have you banging around on the system than listening to me talk about slides. Kind of anti-slide. If you hang out with me for much, you'll figure out I'm not a big fan of slides. So they're great for information, but really for retention and learning, I feel I like on the keyboard much better. So, moving on. Splunk for discovery definition. An event is a single piece of data in Splunk. It's similar to a record and log file. It's kind of the base organizational unit within Splunk. Everything is organized into events. And one of the first things you do when you get data into Splunk is make sure that that event breaking or line breaking is happening properly. It's like anything else. It's garbage in, garbage out. There are, let me take a step back. I talked about the schema on the fly. But even with the schema on the fly, there are a few things you got to know as you're bringing the data in. Otherwise, it's going to get hopelessly messed up. A couple of those are listed right there. The timestamp, got to know the host, the source type, and where you're going to index it to. All of those you have to know at certain times. They're very basic, and Splunk is very good at figuring it out without any help. A lot of times, most of the time, you can just throw your data at it. It's going to figure out what an event looks like, what a timestamp looks like, and be able to pick it up from there. Now, there are some things you can do to confuse it. One of those is throw it through a syslog server. So something like syslog NG, something like that. It adds another timestamp on top of it. So now you have the event timestamp and you have the timestamp of when the syslog server processed it. Splunk is not going to know which of those two you care about. And it depends on how the system works and the way it's configured, where it puts it. So it's very difficult. So those are some things you need to watch out for when you start bringing data in. Make sure that it's getting the timestamp that you want it to. So you can adjust it. It's very flexible on how we adjust it. Basically, you can do a regular expression match to start identifying some of these things. So timestamp being one of them. Another gotcha is if you're bringing in Java stack threads, literally they can be thousands of lines long and still be part of the same event. So, okay. All right. So, fields. Selected fields and regular fields. These fields, again, they're going to change as the data in the search changes. So this field list is generated on the fly, and anything considered interesting is a field that shows up in 50% of the data or more. So if the data selection, if that particular field shows up more than 50% of the time, it's considered interesting. Now, there are fields that aren't in enough of the data to be considered interesting, but you may still be interested in. And you can actually go in and select those and kind of bubble them up to the top. They can become selected fields, and then even if they're not considered interesting, they'll still show up here. In your environment, some fields may be important. The basic three are always going to be host, source, and source type. If in your environment you have, say, a user ID or something like that you will always care about, you can select that so that it will bubble up. Fields are going to give us a lot more precision in searching. So when we first started doing our searches, like Google for the data center, we looked for error. It gave us error anywhere in that event. Now we can actually say we only want to know if the status code says error or if the status says 503. Otherwise, if we put 503 in, which is a web status code, if we just throw that in there, it's going to give it anytime 503 shows up. It could be in not an IP address, but it could be in a serial number, in a time code. It could be anywhere. And that may not be what we want. But we can also then just say status equals 503, and that will only give us events that have the status code field and contain 503 or whatever else it is you put in there. And we'll get into that, and it'll make a little more sense maybe as we get through and go through some examples. Source type. So the source type really is just telling Splunk how to handle the data. There's a bunch of common pre-trained source types, and then there are things that we can do with extensions like the applying applications and stuff to help with that. Field definitions are per source type. They really should follow the CIM or the Common Information Model. That really is a very important function that really Splunk is starting to emphasize more and more. The Common Information Model is simply a way to normalize different fields so that you can then compare data across different source types. So it's really normalizing what the host name is. Is it host? Is it host name? Is it host NM? Is it host? Whatever all of that is, it normalizes it into one thing. So that instead of remembering, oh, this is a firewall, that's right, it's source underscore ID or SRC ID. You don't have to remember that. You just say, yeah, I want to know what the source ID is, and you can search across all your different data types. So most of the newer applications are built based on this Common Information Model, and they'll say it usually if you're installing it. So if you're going to download and install an app, and there's two versions, one's CIM compliant, the other one is not, always go with the CIM compliant. All right. So I'm going to kind of go through this first, and then I'm going to kind of turn you loose on this. So this demo, we're going to use the application intelligence demo, and I showed you some of this a little bit earlier. So I'm just going to kind of step through this. This one. All right. Got to bring up the right window. There we go. So the first thing we're going to do is we're going to look at our web logs, which I happen to know is source type equals access underscore combine. I don't like to type, so I'm just going to shorten it. So now notice our field extractions over here. So we've got most of them. Since it's a common data type, most of the fields are going to be the same. So that's why you only see one field that isn't considered a interesting field. So some of the data, one of those isn't showing up in everything. If we have more variable in our source type, of these are going to be just going to change quite a bit. So here we're looking at our logs. So let's do a little more detail. I'm going to say action purchase status equals 503. And oops, all right. Okay. There we go. Okay. So let's look at the host. It's all that it's showing up on. So 503 is bad. 503 is a connection error, I believe. So we're looking in here, and it's all on these Apache servers. So let's take a look at, that looks fairly normal. Looks like we're not necessarily, it's not a particular server since it's evenly spread across all three. So let's take a look and see if we can dig in a little bit deeper here. All right, I'm flipping back over to my notes here. Let me do this a little different. Nice. There we go. All right. We're going to do this the cheating way because the more people that are watching me type, the less accurate I type. I don't know why it works that way. It just does. Maybe it's performance anxiety. All right. So let's narrow down a little bit. Let's take a look at the Webster layer. So we're looking at custom time. I'm going to look at I'll look in the last 24 hours just to make things easy. Okay, so now we're getting all of the WebSphere logs. And let's see if we can narrow it down a little bit more. So there's still a lot of information in here. Let's see if we can look for any exceptions. If I could type, I'd be dangerous. See what I said about typing? Okay, now we're getting a little more specific. The item found exception occurred. So we're getting a little closer. And let's see if we can, get code, status codes here. Punctuation's a nice, punct is an interesting field too. Real quick, all it is all of the punctuation in an event. And if you're really trying to get to know your data and figure out, this is a really good way to look at the types of data in your system. Because all it does is it flushes out all the text in between the punctuation and gives you what's left. So if you want to compare it at a very high level, we've got 3 different types of events we're looking at right there. And you can tell it pretty quickly using punct. So we got Nix all logs, we got error logs. All right, so let's narrow it down a little bit more. Say, well, we don't want to care about get policy. All right, so now we're down to 84 events. Now, if we dig down in here, we can see if we can figure out what's causing our problem. So it looks like we're having a connection problem to the database. Fatal connection error from resource for the database. WPDB DS5. So, all right. Now that we've dug down to here, let's take another step and let's take a look at what's going on in our databases. So let's change our source type over to MySQL. Oh, we got a bunch of critical messages. Let's see if we can figure out what's going on in here. Oh, we've got a shutdown complete. Oh, that might be a problem. So right now, what we've done is we've taken it kind of down from a problem where we're getting 503 errors, but the 503 error wasn't coming from the web server. And if we were to try and do this without Splunk, we would have to go to each one of these tiers separately. And a lot of times, we'd have to go to every server individually. Like we looked at all 3 web servers. If we didn't have Splunk or something aggregating the log files, we'd have to log into each one of those and run the same search, and then manually correlate the results across the 3 looking for a problem. And then, in a normal environment, what will happen is the web server guys are going to go, well, it's not a web problem. And then that's the extent of their responsibility, so they just kind of leave it at that. Where then someone else has to come in and look at, well, the WebSphere guys are going to look at their layer. So they're going to log in and they're going to say, oh, look, it's not a web server problem. It's not WebSphere. I'm having a problem connecting to the database. It's a database problem. And they're going to leave it. And the time's going to go by, and then you're going to get the DBA involved, and he's going to come in here, and he's going to look at his logs and go, oh, crap, I got a disk full. I need to fix that. But it's not very efficient, and in most organizations that I've worked with, it's very difficult to get to this layer this quickly. I mean, we were stumbling around and kind of looked down through it, and we were able to get down to the disk full message very quickly, within minutes. And that's without knowing our environment that well, and that's not me being either a web guy or a DBA guy. Okay, my background is security, so I know a little bit about a lot, and a lot about very little. So digging down into here is not my forte. But even with that, we can dig down in here and we can find out what is the problem fairly quickly. And do it all in one system in one place with just a couple of different searches. Now, the really cool stuff comes when we start looking for things like this. This is full. Oops. So let's look for this particular error message. And now I want to save that as an alert. This full alert. We can give it a description. We can either schedule it to run, or we can run it as it comes in. We can run it every week. I'm going to schedule it. I'm going to run it every hour. The 0 past the hour. You can get really creative on how you want to run these. And I want to trigger if the number is greater than, say, 1. Because this is a fairly important error to me. If the disk is full, I need to know. Somebody needs to do something. So I'm going to say, I'm going to run this search, this one we did. So I'm going to look at my SQL database source type for a message, disk is full, and anytime I get a result greater than 1, I'm going to trigger an alert. Now for this, I'm just going to trigger it into our triggered alerts, which is in this upper right-hand corner. You'll see a little messages window. That's where it will send. We can also send an email, or we can run a script. We can also do some hold-down things like when they're triggered, you can execute the action once or for each result. You can throttle it. You can sleep it so that you're not denial of service in your email system every time something bad happens. So very flexible. So, but once you've identified the problem, now we can get a little more proactive. And now we don't even have to run the search. At the top of every hour, it's going to run it for us. In fact, let me actually change that. I'm going to say schedule at, let's see, 30 minutes after the hour. That way it'll actually run while we're here. So at 30 minutes after the hour, we should get an alert up here in this message window. So anyway, it's a lot easier to troubleshoot and dig into issues here within Splunk where everything's under a single pane of glass and easily searchable. And once you've done this a little bit, it's really easy to start counting things. So we can actually, let's look at our search again. Let's go source type equals MySQL database. Look for disk is full. And give me a stats count. So tell me how many of those happened in our given time frame. So our time frame right now is all time, so we've had 84 of those messages as long as this system's been out. And this is a test system, so we brought it like this. So we've had 2 of them in the last hour. So we can actually dig in and get more information about what they are. So it looks like we've only got the one host that's coming from MySQL. So we can actually count them by host. We can count them by, by errors, depending on what our search is. We can get very in depth into that. Okay, so let's do this. Let's go into lab number 3, and this is. I need to do something really quick here, so that you guys will be. I'm going to enable a script here. All right. So we are in the help desk, and we've just got a phone call saying that users can no longer get to a web app. And in this particular case, they're trying to get out and fill out their expense reports. And if this was me, I'd be very irritated because I don't like getting expense reports anyway, and now I can't even get to the server. So we need to go in and figure out what's going on and what happened and why people can't get out to this web system anymore. So let's do the next lab, which is lab number 3 for Splunk investigation. So I want you guys to run through this. This is going to take a few more minutes, so I'll give you about 15 minutes. I'll check back in at 30 minutes after the hour, and I will be here if you have any questions. Otherwise, let's see if we can go ahead and run through it, and let me know if you guys have any trouble. All right. Hopefully, you guys have had a chance to kind of move your way through that and are ready to move on. Looks like we got a couple ready to move on. I don't want to spend too much time on this, just because we won't be able to get through the rest of what we wanted to cover today. We are kind of coming down on the downhill slide. We've got one more lab, and then we'll show you things returning back to normal after we simulate the fix of the problem you guys are looking at right now. So I'm going to go ahead and move on unless I see a bunch of red check marks. You guys need more time. We'll go ahead and roll on. I'm going to go ahead and clear them, and then we'll go ahead and move on, and we'll kind of go through what you went through. We'll review it really quick, and then we'll move on to alerting, being a little more proactive. Then we'll go through an alert or exercise to create a dashboard and an alert, and then we'll talk a little bit more about it to wrap it all up, and then we'll turn you loose. So, all right. So what do you guys look for? First thing we did is we looked for concur, right? Concur asterisk. So give me any event that has the word concur in it or any variation of it. And what we found is at some point, we immediately, or some point very recently, we started getting a bunch of 404 errors. So 200s, right now he's looking at the status, or you're looking at status. I like status description because I'm not a web guy. So status description is a lot easier for me to understand than say maybe status, because I don't speak web natively. I have to have a translator. So let me go ahead and bring it up here. I'll pop it over here. So this is what it really looks like, and this is when it started showing up. So if you actually look at over here, we've got the status. We've got 200 and 400, so we've got the description, which is okay and not found. That makes a lot more sense to me. So now I've got okays and I've got not found. That looks to be a problem for me. So I want to look at it over time. So all I did is click on it and said, give me the chart over time. And right here, that looks suspicious to me. So I know that I went from 0 and then it started climbing, and then it's kind of peaked out. But where it was close to where the traffic was before. So that's, to me, that's a bad sign. So we need to investigate more of that. And that's exactly what the lab is for. So you kind of see where it's made the transition, and then you can start digging into it more. Now, in this particular case, there was a remedy change ticket about the firewall that someone went in and removed a rule for remedy, or for, not remedy, sorry, concur. So somebody went in and took the rule out, and now everything's starting to fail. Everything's starting to fail. So real quickly, we were able to figure out, well, what's the problem, track it down to a point in time, and then we can go to that point in time and see exactly what was going on at that point in time. And then we can go back and find the ping control ticket and say, oh, you know what, this is bad. And either this was messed up and it shouldn't have happened, or now you just need to let the user know that, you know, you can no longer do expense reports, which I'm sure would break their hearts. I'm sure break one. Okay. So let's talk about a little bit about automation. So once we've done the investigation, we now have these objects that are created, these searches, these reports, these things that will help us in the future to make this faster. And we can start by just saving those, like we did, saving them as a report, or basically just a saved search, so that you can just go back in and run that search anytime you want to. You don't have to think about it, or you can actually build it into part of the dashboard. We'll do that here as part of this next exercise. We'll build it into that. So we really want to get from, we want to enable rapid investigation. And that's really the point of this whole bootcamp, is to kind of talk about how can we enable rapid investigation? How can we combine all of these different data sources, put them all into a single place, and make it searchable in a way that you can do it quickly? So that's rapid investigation. Now, once we've done that, once we've investigated, once we've found the problem, we want to make it proactive, so that instead of an end user calling you to say, hey, the firewall rule went wonky and now I'm getting all these 404 errors, we can look for 404 errors in our environment, and if they take a sudden spike, we can be investigating that, or we can get an alert saying, you know what, 404 errors are now above threshold, whatever that threshold is. I'm sure a certain number of 404s are going to be normal, or not founds are going to be normal in any environment. But if they suddenly go from, say, 100 to 100,000, we know we got a major problem. And we can start investigating it before the end users call up and say, hey, the internet's down, which is one of my favorite little conversations. So anyway, that's really where we want to get to, from rapid investigation into proactive monitoring. And from proactive monitoring, we want to spend more time in getting into business intelligence and then into operational and business intelligence. So that's really the kind of the progression. So anytime you spend a lot of time finding a search or creating a search that provides good data, it's a good idea to just go ahead and save it. Now, when you save it, you have an option to either share it with everyone or you can just keep it private. And by default, private is the option. And again, you have to have rights to do this. Power users, depends on how much you want to restrict it. You can then share it with everybody within the app. So if you have, say, the guy, we talked about the guy earlier, the one who knows the data and knows what to look for, maybe he's the one that creates searches for you. And so he has the right, or he has rights to share those searches with everyone within that app or within the organization. So he can write the search, save it, share it. Now, instead of me having to know what to look for, I can just go in and say, hey, run this search. And now I can start digging in and get short-circuited and really reduce the amount of time it takes to troubleshoot issues. So to leverage the knowledge of someone with all that experience without having to have them on site telling you, running it or holding your hand or doing it for you. So very, very powerful stuff. So we can create that alert and then we can create it as a dashboard. Okay. So you should have created this already. You should have saved the report. So once you've saved the report, you can go back in and run it at any time just by going on to reports, finding the report. Now these buttons here, this is all of yours, this app, those can really be helpful in finding things if you've got a bunch of saved searches. You can also do a filter. You can filter based on, just like anything else, any criteria you think will help you get to the data. You can also go to settings and run the reports there. So that would be, pop that window up. Under settings, you can get in reports here. Searches, reports, and alerts. You can change the app, and we still haven't really talked much about apps. We'll finish up with apps. But that basically is the context everything's created in. So if you can't find something, check your app context. That's a good rule of thumb. All right. So let's get back over here, go to the shadow PowerPoint, and okay. Anything that can be searched on can be alerted upon. So anything that you can find in a search, you can then turn into an alert and have it proactively monitor for it. Now, there's three things you can do with an alert. You can list it in the triggered alert, like I did, which we'll see here in a few minutes. If it's not in there already, I think it's set up to run after that. Let's take a quick peek. Nope, it looks like it didn't trigger. I must not have set that wrong, or I missed the window. Anyway, so this is the triggered alert. You can set up send an email, and through email you can send it through SMS, however you want to do it. And then this last one is very powerful. You can actually have it launch a script. So you can create a custom script to actually resolve problems. So say that, let's see, real world example. We had a process that wasn't very, or a program that wasn't very well written, and the process would occasionally go runaway. And we would know it was in the process of that. As soon as it got above 90% CPU utilization for that particular process, we knew it was gone, and the only thing we could do was restart that process. So the first time, tracking that down took days and hours the first time. It literally, I think, took 2 days to find it the first time because it was on multiple servers. And anyway, From there, we actually knew what to look for, and then once you got the right person on the line, they were able to find it. It was pretty quick. And then we got to the point where, you know, everybody was aware of it. So if somebody reported saying, hey, the server's slow or we can't get to this, everyone knew to just go in and restart it. Now, with Splunk, what we were able to do is set up an alert to look for that condition. So we saw, anytime we saw an event that said that that particular process, the CPU utilization was greater than 90%, send us an alert because we knew we were going to get it from the end user eventually, so we could go in and restart. Okay. From there, somebody wrote a script that then, you know, once we got that alert, we just run the script. And then we were able to take the user out of the loop and just automatically run the script. So anytime this action would occur, it would automatically run the script, it would restart the service, and then it would index the result, saying, hey, it was up. And we would get an email that said, hey, this service went above 90%, we ran this script, now it's at 10% or whatever it went. So we were able to take the human out of the loop and really accelerate the resolution of that problem. So, now, again, yes, the right answer is to go back and fix the problem and get the guys who wrote the program to fix it and make it so it doesn't do that. But I don't know about you, but in most of the environments I've been in, the right answer isn't always available. Sometimes you just got to make it work. And so that was our way to get to it. Now, without Splunk, the early investigation was without Splunk, and that's why it took so long. Once we got Splunk in there, we were able to look at it in one place and set up those alerts. It got really easy. And then we were able to take the user out of the loop once everyone was comfortable with what the solution was. So very powerful stuff. And basically, anything that you can script, you can trigger that script and it'll run. So save it as an alert flow. You know, you guys can, I think the challenge exercise is create an alert. So you may have already run through this. Otherwise, this is the process. You give it a name, whether you want it to be real-time or scheduled. Brief little blurb about real-time. I noticed if you read through the lab, it said something about dedicating a processor on a real-time search. Well, let's talk about that. So a real-time search in Splunk terms means as it's being indexed. So there's actually a fork in the processing as data is being indexed that if you have a real-time search running, it will actually send it to that real-time search as well and do it as it's being written to disk. So that's real-time. The problem with that is it's very processor intensive. In fact, it does dedicate a CPU to that search. So if you, as you can see, or as you can think, that if a bunch of people are running real-time searches all at the same time, bad things are going to happen. You're going to run out of processors and things are going to slow down. It's going to be ugly. So real-time is, first of all, end users typically can't even run a real-time search. You have to be at least a power user to run a real-time search. And there are cases where it's very, you need that real-time alerting. Probably a good example would be that disk full error. That is something we want to know as soon as that happens so we can go out and fix it before it becomes even more of an issue. So if we ever see that, we'll kind of keep an eye on it, and if it ever triggers, we want it to alert us immediately. So that might be a good one for a real-time search. And it might be worth dedicating that process to it. If it's something that's less important, say, I don't know, if it's not as time sensitive, maybe you could just run it every 5 minutes or run it every hour. Just depends on what it is you're looking for and the priority it is to your organization. So, anyway, saving alerts, that we already talked about real time. I wanted to get that in there. So, very flexible on when you run it. You can also get into cron terminology. If you're an X-Unix guy or a Unix guy and you like the cron terminology, you can get really crazy with that and use that as well to schedule the searches. So reports and alerts are really just the same type of knowledge objects. They just have more fields. So a report has the search screen. A scheduled report has a schedule and a search screen, and then an alert has all three of those defined. So they're really the same knowledge objects with more value or more information layered on top of it. So a simple dashboard is very easy to create. In fact, we're going to create one here in the next one, but basically once you have your search the way you want, like the looking for the status descriptions, you just save it as a dashboard panel. You give it a name, you can either create a new dashboard or use an existing dashboard, and it's that simple. It's very quick. It's very easy to create dashboards, and they're very powerful. Once you've created your dashboard, you can go in and you can edit it. You can change the search. You can change the visualization. Maybe you want a pie chart instead of a line chart or a bar chart, or you can change the labels. All of that can be done once it's been created. You can also drag and drop those things around and create a dashboard that has multiple panels. Maybe you want 3 panels in a row. And as you look at some of these dashboards that you've been poking around the system, that's all that's been done. They just created these panels, they moved them around, and that's how these dashboards work. Okay, so give me just a second. I'm going to start another script. And then we'll go through this last lab, and then we'll finish up and get you guys out of here. Hey, come on. Where'd it go? Oh, there we go. That's right, I moved it. So here, I'll show you how to do this. So we've just created a script that runs this data for us. So I happen to know it's on page 2. So I'm just going to enable it. Okay. Now, let's do lab number 4. So we've got users reporting that the internet is slow, which I'm sure in your organization never happens. But where I used to work, we used to get this every once in a while. So that's kind of the one we're looking for. So go ahead and run through this. If you have any questions, like always, let us know. I'll give you about 10 minutes, and then we'll take the last 5 minutes. We'll finish up. We'll talk real quick about apps, and then we'll get you out of here. Okay. Only a few minutes left here. I don't want to keep you guys too late. I just want to cover a couple more things, a little bit about apps, and then I will change or switch off those scripts that are running so you guys can see the return to normal, which would be the last thing, and then we can go from there. But apps, by definition, self-service out-of-the-box extensions with Splunk. Apps are not traditional apps in the sense that they are, like Angry Birds or Candy Crush or something you download off the App Store, put it on there and play. So these are more of extensions. They are more templates rather than programs that do things. There are a couple of exceptions that prove the rule. One of those being like DB Connect or the VMware app. Those contain things that are more complex and actually do and run different programs. So, but for the most part, Splunk can be divided up into two major categories. There's getting information or getting data in, and then getting information out. So an app is going to cover both sides of that. They also have things that are called TAs or technology add-ons. Technology add-ons cover getting data in properly, what the field should look like, what the timestamp should look like, all of that. But they don't necessarily have dashboards and visualizations with it. Now, most of the apps on apps.splunk.com are free. There are a few that they consider premium. I think there are 5 right now. That changes from time to time, but they are listed here: Enterprise Security, VMware, PCI Exchange. I think the Active Directory ones also. Yeah, anyway, they are clearly listed as premium apps. So the rest of them, there's, I think, some 400 plus of them now are all free. And you can download it and install them and extend the functionality without too much trouble. So here's the apps repository. I encourage you to go take a look out there, log in, see what's available, see what's out there, and take a look at them. A couple of the apps we have installed here that you're welcome to poke around on. There's the Cisco Security Suite app. This one has recently been changed quite a bit. With the latest version, they've gone to kind of modulars. So where you can install the module that covers the technology and then the overarching dashboards and such that are in the Cisco Security Suite app itself. So we can help with that if you have any questions. Otherwise, you can poke around in here and kind of see what it looks like, what's available. I'm not going to spend a lot of time on that since we don't have much. Application Management app. This is a little bit about what you can look at or what you can visualize with some application management. There's a demo that goes along with this that we don't have time for. So I'm just going to leave it in that. You're welcome to log in and poke around and kind of look through things. Basically, somebody made a change to the database environment without a change control, which is what this is showing, and that's kind of the root cause of the problem. And you can pretty quickly, even without knowing a lot of what's going on, just looking at the dashboards, drill down and find that stuff. So what I'm going to do now is I'm going to go ahead and switch off the scripts that are generating that data for us. And we should see, if you've got your dashboard open, you should see the return to normal. And they should go back to, the DirecTV load will go away because people are no longer watching the World Cup, which is what that simulation was about. Or whatever the sporting event is, and then that's kind of it. So some great case studies. If you guys are looking for more ways that Splunk can help you, you can pop over to this link here. It's got 100 plus case studies from every kind of vertical you can think of, from healthcare to banking to government, you name it. There's somebody out there with a use case study about it. So that's really all we had for you today. So I want to thank you for your time, for going through it with us, and for being our guinea pig today. If you have, I'd like to encourage you to leave some feedback on your way out. That'll just help us get better. If there's things you liked, you didn't like, just let us know. We can maybe tweak them a little bit. If there's things that you'd like to know more about, or if there's a Splunk bootcamp you'd like to see, let us know on your way out, and we'll see what we can do to provide that. Otherwise, I'll let you go from here. There are a couple other slides about some of the hardware sizing here at the end that are included. They're part of the download, and you can look at them there. If you have any questions, feel free to let us know. I'll stick around here for a few minutes, probably for the next 10, 15 minutes. If you do have any questions, I'd be happy to answer them. Otherwise, my email is listed here, and feel free to shoot me an email. So again, thanks for your time. I appreciate it, and have a great day, and happy Splunking.